All right, so a function, if we take a look here, well, first we need to know what a relation is. And a relation is just like ordered pairs, okay? If x is 3, y is 7, okay? That's a relation, all right? So relations can be written as ordered pairs, okay? And all ordered pairs are listed x, y, input, output. So your input is your x, your output is your y. You could also make these as a mapping, okay? And you're going to have to do mappings yourself, so kind of pay attention to how this is done. You list all your inputs, so you list all your x values, and then you list all your outputs, or all your y values, and then all you do is draw arrows going to where they match up. Okay? Easily done. So for example, the coordinate -3, 4 is represented right here. -3 is your input, 4 is your output. You have an arrow drawn between the two. Okay? We've also seen table of values. We've seen that before, just a T-chart. That's all it is. Okay, that's a good way of representing a relation, or graphing the points. Also a good way of representing a relation. Okay? So, relation versus function. Now, I haven't talked about what a function is, but just think a relation is everything we've done in class. Every equation we've dealt with, every set of coordinates we've dealt with, all of those are relations. Okay? So now, what's a function? Well, a function is a relation, but it's where the input has only one output. Okay? The input has only one output. So, I like to think of functions as a machine. Okay? I like to think of functions as a machine. Whatever I throw into the machine, I'm going to get only one thing coming out of the machine. Okay? That makes a function. If I throw one thing into the machine and I get 4 things coming out of the machine, that is not a function. Okay? One thing in, one thing out. That's a function. Okay? So, let's take a look at a couple of examples here. If we take a look off to the side there, our first example A, we have a mapping. Okay? We have a mapping, and we have our inputs and our outputs. So, taking a look at the first input, does that have only one output?
Yes.
Yeah, because there's only one thing that it's pointing to, right? Yeah. Does -1 have one output? Yeah. Yes. Does 3 have one output? Yeah. Does 6 have one output? Yeah. It does not matter that -1 and 3 both have the same output. That doesn't matter. What matters is that these are only going to one number. Okay? So this is a function. Let's look at the next one. For the next one, is -2 going to one output? Yes. Is 1 going to one output? Yes. Is 2 going to one output? No. And so right there, 2 is going to 2 different outputs. That makes this not a function. Okay? So essentially, let's do just a very simple example here. So off to the side here, let's just kind of write a simple example. So if I have a mapping, let's say I just got one number here and I've got 1, 2, 3 over there. Okay? So if this one number goes to all 3 of those, is that a function or is that not a function?
No.
That is not a function. All right, well, let's do the same thing, but flip it around. So, if 1 goes to 1, 2 goes to 1, and 3 goes to 1, function or not a function? This one is a function. Okay? Questions? So if we're just looking at ordered pairs, you could try to figure it out just by looking at your ordered pairs. Or if you want, you could draw a mapping. Okay? So if you're going to draw a mapping from this, you're going to go through and give yourself either, you can do this with rectangles rather than ovals if you wanted to, but your input is which values? The x's. And so we look at all of our x's and we list them. Now you only have to list it once, like 0 shows up 3 times. We only have to write it down once. So we've got -5, -3, and 0. Now the output is going to be our y values. And our y values are there. So we have -1, 0, 2, and 5. Well, now all we need to do for our mapping is draw where they go. So looking at the first point, it's -5, 2. So -5 goes to 2. Second point is -3, -1. So -3 goes to -1. 0, 0. 0, 2, 0, 5. Function or not a function?
Not a function.
Not a function. Now, does anybody, yeah, question?
When you do the charts, do you have...
You can look at just the ordered pairs and decide whether or not it's a function or not. If you look at the x values, if any of your x values repeat, then it's not going to be a function. Because that means that that one input is giving you multiple outputs. And we can't have that for a function. Okay? Again, think of the machine. One thing in, one thing out. Okay? All right, any other questions? Then quickly let's look at the next one and tell me function or not. Function, how do you know? If you look at all the x's, look at all your inputs, they're all different. Right? So they're all different. This is a function. Okay, good. Next, we want to talk about domain and range. Domain and range. Now, things you want to remember, and the nice thing is that this always goes alphabetical order. X always comes before Y, alphabetical order, right? Okay. Input comes before output in alphabetical order. Domain comes before range in alphabetical order. And so it all runs that way. X is input and domain. All means the same thing. Y is output and range. It all means the same thing. Okay? So we have 3 different terms for the exact same stuff. Okay? Domain and range simply means X's and Y's. So for that first example, we have a relation, and we want to know what's our domain. All we're doing then is listing the X values in that grouping. And make sure, again, we do it in order. Okay? So our domain here, if we go in order, looks like, actually it's already in order. Our domain is going to be -3, 0, 2, 9, and 23. What's our range then? -99, -18, 0, 7, 14. Put them in order. Okay? That's all you're doing, domain and range. Domain is the X values, range is the Y values. Okay? So, real quick, do the next one. Okay, we should be getting the exact same thing for our domain and our range. -4, -3, 0, and 4. Okay, so sometimes a relation is going to be given to you as a graph. Okay, not as a list of points or not as a mapping. And you're going to have to look at the graph and say whether or not it's a function. Okay, So there is a way of looking at this. There is a simple test to do to tell you if it's a function or not. And that simple test is called the vertical line test. Okay? Vertical lines go up and down. All right. So the vertical line test. Let's take a look at this graph here. So the blue is the relation we're talking about. Okay? The blue is the relation we're talking about. And then the red line is our test. Okay? So you'd put in a vertical line, and we want to see, is this a function? Well, in this case, it's not a function because the vertical line test says that we put a vertical line anywhere on the graph. Okay? And if that vertical line crosses our graph we're testing in more than one spot, it's not a function. Okay? So like this example, it crosses it in 2 spots. Therefore, it's not a function. Okay? Now, why does that work? Well, a vertical line has an x coordinate. Every single point on that vertical line has that exact same x coordinate, right? That's the idea of a vertical line. Okay, so then that means this point has the same x coordinate as this point. They have the same input, but they have 2 different outputs. So by the definition we talked about on the front side of your notes, this is not a function. One input cannot give us 2 outputs. Okay? If you put one thing in, you need to get one thing out only. All right? So, vertical line test, if it crosses in more than one spot, it is not a function. All right, so let's take another quick look. I'm just going to draw another function here. So if I have one that looks like this. Okay? We want to use our vertical line test. Now you can actually draw in vertical lines if you want. You can use your pencil and move it across the graph if you want. Or you can just kind of visualize it in your head if you want. Okay? But you've got to be putting a vertical line on here and saying, is it going to be a function or not? What do you think?
No.
No. Remember, the vertical line test has to work anywhere you put it. So I can't look over here and say, well, if I put a vertical line there, it only crosses in one spot, so it must work. It must be a function. Well, you're right. It works there. But does a vertical line work anywhere? No. Because if I put it here, it now crosses in 3 spots. Okay? So this is not a function. Okay? Got the idea? All right, good. So then the last thing that we want to talk about today, well, actually we want to do a couple examples here, but let's not jump too far ahead. So, part A, example A here. Function or not a function? This is definitely a function. Any vertical line we draw is only going to go through one of those points at a time. Okay, so this is a function. How about example B? Not a function. Because if we put a vertical line here, it crosses 2 points. Or if we put a vertical line here, it crosses 2 points. So, not a function. Okay? All right. The last thing we want to talk about then is function notation. We have seen this before, and in the past I told you guys, if you see f of x, you need to think y. And you still need to think y. Okay? But we need to be able to use function notation now. All right? So, function notation, first off, a function rule is just an equation of a function. Don't get confused if they say a function rule. It's just the equation. Okay? But function notation is where we take the output, the y value, and we replace it with that f of x. Okay? Now, f of x is only used if you're actually dealing with a function. We can't just put f of x on any old equation. It's got to be a function. Okay? So, what this means is that we have a function with respect to x. Or in other words, a function where x is the only variable. Okay? And then if we want to evaluate this, when we substitute into that equation, we don't keep this as f of x. We change it to whatever we're plugging in. So now if I plug in 1, it's now f of 1. And then I plug in for 1 into my equation. So for example there, 3 times 1 is 3 plus 2 is 5. So therefore my answer would be f of 1 equals 5. Rather than saying y equals 5, it's now f of 1 equals 5. Okay? Why do we do this? Why might this be handy? Well, first off, this tells us that we're dealing with a function. Okay? It tells us what we put in for the input. And then we can also see what then that corresponding output is going to be. So all that information is held there. That's why we use function notation. We know we're dealing with a function, we know what our input was, and we know what our output now is. All in our answer. Okay? Questions? If we take a look at our first example here, we have 3 input values. We want to write the output. Okay? All we're doing is learning a new notation. Nothing else has changed. This is pretty straightforward stuff. So f of x equals negative 4x plus 1. That means if I plug in negative 2, I know that f of negative 2 is going to equal negative 4 times negative 2 plus 1. Well, what is negative 4 times negative 2? Positive 8. Plus 1 is 9. So therefore, f of negative 2 equals 9. That's it. That's all we're doing. Okay? That is all we're doing. All right? Now, something that you might see on a test or on homework or things like that, rather than doing this, rather than giving you just 0 and telling you that's the input, they may ask you, knowing that this is your function, what is f of 0? Okay, well, all they're saying is plug 0 in for x. Okay, so therefore f of 0 is negative 4 times 0 plus 1. What's negative 4 times 0? 0. What's 0 plus 1? So f of 0 equals 1. Okay? That's all you're doing. So I will give you guys a minute to work this example. Those are 3 different values. So I want you to find f of negative 3, f of 0, and f of 1/4. Do not use your calculator for f of 1/4. I don't want you taking 0.25 times things. Don't use the decimal, use the fraction. Get started. So for f of negative 3, we're plugging negative 3 in for x. So you should have negative 2 times negative 3 plus 5. Negative 2 times negative 3 is plus 5. So f of negative 3 is 11. How about f of 0? Negative 2 times 0 plus 5. Negative 2 times 0? 0. Plus 5. So f of 0 equals 5. Now, f of 1/4, you should not be using a calculator for this. All right, so plugging in, we have negative 2 times 1/4 plus 5. Well, multiplying negative 2 times 1/4 gives us negative 2/4, which reduces, right? Yeah, 2 goes into itself once, goes into 4 twice. So that means we have negative 1/2 plus 5. Well, now we need a common denominator. Because right now, 5 is over 1. So I got to multiply the top and bottom by 2 to get my common denominator, which makes this 10 halves. So what is negative 1/2 plus 10 halves? So f of 1/4 equals 9 halves.